So we left off, we were, what's that? I don't care, whatever unit we're on. The next unit, how's that? Okay. Yeah, I think it is unit 4. So unit 4, we're going to be looking at these trig things. You're going to have a good folder for this unit because most of this is not going to be in your textbook. So you're going to have a lot of worksheets and packets and stuff to work on. So we want to look at how do we use this trig to find the area of a triangle. Now we've looked at several strategies for finding the area of a triangle. If we have a right triangle, let's say we're given that this is 17 inches and this here is 8 inches, how do we find the area? Oh, you're thinking hypotenuse length. Area would be, yeah, 17 times 8 divided by 2, which is going to give us 68 inches squared. If we don't have a right triangle, we can still use that same strategy as long as we have one altitude. Remember, from a vertex to the opposite side at a right angle, that is called an altitude. Let's say that is 6 feet, and this across here is 13 feet. How do we find the area of that triangle? 13 times 6 divided by 2, exactly. That is 39 square feet. So it's still the same formula. The next generation of area of triangle was something like this. How did we find the area of that? That was Hero's formula. How did Hero's formula work? Which is called the perimeter, right? So 8 plus 9 plus 11 would be 28 feet here. Then what? Semi-perimeter first, right? Divide it by 2 gives you 14 feet as the semi-perimeter, half the perimeter. Then you do the square root of 14 times 14 minus 8 times 14 minus 9 times 14 minus 11. The square root of 14 times 6 times 5, 3, 35.50. That's in feet, so this will be square feet. Well, today we get to move past that into trig. Now we're going to come back to this particular example. There is still a way we can do that one with our trig stuff and not have to use Hero's formula. Hero's formula might be still easier for that. Let's take a look if we have a triangle like this. We're going to call it ABC. So this is little a, little b, and little c. And we're going to give you that side A is 40 feet, side B is 52 feet, and angle C here is 56 degrees. To find the area of a triangle, I need a base and I need an altitude that is perpendicular to that base. So if I'm using that blue line as my altitude or my height, how could I find the length of that? Well, since an altitude by definition forms a right angle, we have a right triangle here. What we know about that right triangle, obviously this is the right angle, we know this angle is 56 degrees and this is 40 feet. How would I find the length of this side here? According to this angle, the 40 is which side? Hypotenuse, right? It's across from the right angle. Adjacent would be down here. that is adjacent, but it's the hypotenuse, so it's the hypotenuse. This is the adjacent leg. X is the opposite side. So we have the hypotenuse and we're looking for the opposite side. What trig function uses opposite and hypotenuse? Sine. So let's fill in what we know. Do we know the angle? 56 degrees. Do we know the opposite side? No, that's what we're trying to find. Do we know the hypotenuse? That's the 40 feet. So since we are looking for a missing side, we make it into a proportion. So we put our trig function over 1, and we cross, multiply, and divide. So this is going to be the sine of 56. Make sure you close your parentheses. And 40. 33.16. So this distance here back here. This distance here is 33.16 feet. What do we do with that? Multiply it by this distance, right? And then divide by 2. 33.16 times 52 divided by 2 gives us the area of that triangle. It's 862.20. That'll be square feet. Well, let's take a look at what we did here. To find this value here, it was the sine of 56 times 40. 40 is side A here. So that is, this length is A times the sine of angle C. Does that make sense? Then to find the area, we took that amount, we multiplied it by the 52, which was side B. So that's B times A times the cosine, or not cosine, the sine of angle C. And what did we do to it? Divided by 2. The area of a triangle, if you have two sides and the included angle, what does that included angle mean? The angle in between the two sides. You can find that area by just multiplying the length of the two sides times the sine of that included angle and divide it by 2. So let's say we have this triangle. Let's say this is 14 feet and this over here is 25 feet. Let's call this 41 degrees. How do I find its area? B times A, or A times B, times the sine of C. C is the 41 degrees, all over 2. You were thinking a little too hard on that. Oops, get back there. So 14 times 25 times sine of 41. Close my parentheses, divide by 2. 114.81. Those were in feet, so this is square feet. What do you guys think? Not bad? What's that? As long as it's two sides in the included angle. So what if we have something like this? Can I do 29 times 50 times sine of 81? No, why not? Yeah, this is the angle that's in between my sides. That's the angle I need to have. Can we find it? Oh, heck yeah. We got 50 with a sine of 81 degrees equals 29. Equals 29 over the sine of, we'll call this angle B over here. We need to cross multiply and divide. So sine of 81 times 29 divided by 50, excuse me, gives 0.5729. So of course we have to do an inverse sine. Giving us 34.95 degrees. Now, we know this has to be a smaller angle, so we know it can't be obtuse, so we don't have to worry about that. So that's 34.95 degrees. This one over here has to be 65.05 degrees. How do I get that? Subtract from 180. Very good. So then my area would have to be found by doing what? Divided by 2. Very good. 50 times 29 times the sine of 65.05, because that's the angle in between them. Divided by 2. 415.32 square feet. Let's say I have a parallelogram like this, and I tell you that this side is 12 feet, and this side is 25 feet, and that this angle here is 110 degrees. I can cut it across here, and of course, that's going to be two identical triangles, isn't it? The area of this triangle would be 25 times 12 times the sine of 110, wouldn't it? Over 2. Well, how many triangles are in that? 2, so that'd be times 2. Guess what? The 2's can cancel out. The area of that parallelogram is just A times B times the sine of that angle. So, what do we get here? Oops, 110, not 100. Giving us 281.91 feet. Well, okay, here's the big question for you. What if instead of using that angle, I use this angle here? What's this angle have to be? Those two sides are parallel. So you consider this a transversal across parallel lines. It has to be 70. They're either equal or they're supplementary, and they're obviously not equal. So they have to be supplements. So what if I used that angle and the 12 and the 25? Hopefully I get the same answer. Are we going to? Why? Because hopefully the area doesn't change. But why does that work? What's the relationship between those two angles? They're supplements, supplementary. And remember, this is 70 degrees, this is 110 degrees. They both have a 70-degree reference angle. Therefore, they have the same sine. So it will be the same. Okay, I've got a worksheet I want you guys to start on. I'm going to give that to you, and then we'll do a little bit more lecturing in about 20 minutes or so. So our second half, we're going to deal with polynomials. But we're going to deal with specifically regular polynomials. In construction, you're going to deal with really two types of polynomials. Regular, and regular, every side, every angle is the same. It's like the regular octagon, would look something like this, only not screwed up. Or elongated regular. By elongated regular, I mean it might be like this. So it's not really regular, it's been one dimension has been stretched, like here. Or it could be stretched in two directions. Come on. So in this one, it's called an alternating polygon where every other side is the same. All the angles are still the same. In all three of these, all the angles are the same. It's just either a single pair of sides is stretched or more than one pair of sides is stretched to make these polygons. Yeah, and they are useful in construction. These two are probably the most common, having that alternate side or every side being the same. This occurs occasionally at gazebos, decks, pool patios, things like that. It's actually really kind of a cool shape to work with on a house, to be honest. But anyway, let's take a look at a regular polygon and finding the area of it. As always, we're going to let n equal the number of sides. So this figure I just drew, n equals what? 6. Depending on who you're talking to, either L or S is used to equal the length of each side. We're going to use L. Just because, well, it's L for length. What's that? Side. So this one has 6 sides. I haven't given you a length yet. Let's give you a length of 20 feet. So n equals 6. L would be 20 for this one, 20 feet. In a polygon, you can a regular polygon, I should say, you can always run these diagonals through it, connecting opposite corners. And you can create isosceles triangles. All these lengths from the center out are the same, no matter which direction you go. So I want to take a look at one of these isosceles triangles for right now. So here, these two sides are the same, and this side down here is equal to L, or 20 feet in this case. What's this angle right there? Well, what would the angle be all the way around here? 360. How many of these angles make up that 360? 6 of them. Well, it's n. So that angle would be 360 divided by n. So in this case, that'd be 360 divided by 6, or 60 degrees. But what we really want is we want to remember we said on an isosceles triangle, if you drop that altitude from that vertex between the two equal sides to the opposite side, makes a right angle, but also cuts the angle here in half, and it cuts this side in half, doesn't it? So this angle here is half of that, or 180 divided by n. Or in this case, yes, 30 degrees. Make sense? So then down here, this length is L over 2, or in this case, 10 feet, right? Half of 20. So now we can try to find, really what we want on here is not this length, we want this altitude is what we want. So let's find that altitude. So we have this angle here, which is 180 over n. This down here, which is L over 2. We're looking for this here. I'm going to call this X for now. tangent of 180 over 2 equals L over 2 over x, right? I'm solving for x. I'm going to put this over 1, and I'm going to cross multiply and divide. 1 times L over 2 is just L over 2 divided by the tangent of 180 over 2. Or not 180 over 2, 180 over n, right? That should be n. I don't know why I switched to 2. 180 over n. What's that? So that's that height. So what would the area of this whole triangle be? Well, the base is L. The height is this here, L over 2 over tangent of 180 over 2, or 180 over n. All divided by 2, right? Because it's that triangle. Let's do some rearranging here. First of all, L times L over 2, that's L squared over 2. Tangent over 2, we're just going to put this as 1/2. Sorry. Divided by 2, we're going to put a 2 on bottom as tangent of 180 over n. I can combine this with this 2 here to make this L squared over 4 times the tangent of 180 over n. That is, however, just one of these triangles. How many triangles are there in that shape? 6, or n of them, right? So you'd multiply by 6, or in this n, or in this case 6. So what you find is the area of a regular polygon is n times L squared over 4 times the tangent of 180 over n. Let's take a look at that. So what we had here, regular hexagon with side of 20 feet. What's n here? 6. What's L? 20 feet. That's all you need to know to find its area. So the area is 6 times 20 squared. That's n times L squared over 4 times the tangent of 180 over 6. So to punch this in the calculator, 6 times 20 squared divided by, got to put this in parentheses now, 4 times tangent 180 divided by 6. There, close the parentheses for the tangent. Then I have to close the parentheses for this one here. Hit enter. 1,039.23. And that's going to be in square feet. What do you think? Not bad? Some people's kids. How's about this one? You're asked to build a gazebo, octagon gazebo, with sides that are 8 feet long. Find the area of it. Tell me what to do. What's n? 8 times 8 feet is the side, so 8 squared over 4. 180 over 8. Perfect. It's always any regular polygon, n times L squared over 4 times the tangent of 180 over n. So 8 times 8 squared divided by, parentheses, 4 times tangent, 180 divided by 8. We got to close those parentheses twice. 309.02. Do you guys remember last semester we had the area of a regular octagon, if you have the side, was equal to 4.2 2875 times the length of the side squared. Oops, I got my constant wrong. Actually, I looked that one up. So the area of a regular octagon is 4.8275 times the length of the side squared. That's a formula we gave you last semester. So 4.8275 times 8 squared. And there it comes out. That's what we got 309.02. That's 308.96. That's just round off errors. What do you think? Finding the area of these regular polygons. I can get it drawn right. One of these days I got to work on my artistic ability. There. Let's say this is 18 feet on a side. Find its area. Assume it's regular. So what do I put in here? Five times 18 squared over 180 over 5, right? So 5 times 18 squared divided by parentheses 4 times tangent 180 divided by 5, close, and go. 557.43. Okay, let's say that this here is 12 feet across, this is 20 feet, and this piece over here is a portion of a regular octagon. How would we find its area of that whole figure? If I cut that across there, what's this angle here got to be? What's this angle? What is the angle of a regular octagon? 180 times 8 minus 2, right? Otherwise known as 1,080 degrees. That's the angle sum. If I divide that by 8, I get 135 degrees. Each angle here is 135 degrees. What does that help us with? How do I find the length of this side here? Do you remember? You can do it. Length of the side here. If I call these each S, right? It's not 8S. What's this length going to be here? But what's this angle? There you go. That's got to be 45 degrees there. This is 90 and that was 135. 135 minus 90 makes 45 degrees. So that makes this length here Well, cosine of 45, actually sine of 45 would work too, equals that length over s, right? So s times the cosine of 45 equals that length. S is the length of the side here. So this total length across here is s times the cosine of 45 plus this length is s plus this length is s cosine 45. That all has to add up to 12 feet. What is the cosine of 45? 0.707, right? Times 2, because it appeared twice, right? So the cosine of 45 plus cosine of 45 adds up to 1.414 plus 1. This is 2.414s equals my 12 feet, right? So what do I do to the 12? I divide by that amount. 4.97 is my length, s. With me so far? So s here is 4.97 feet. Everybody understand how I got that? Substitution, there you go. So what would the area of that full octagon be? Well, it'd be 8 times 4.97 squared over 4 times tangent of 180 over 8. Otherwise known as 119.29 square feet. But that'd be the whole octagon. I just want this much out here. How do I get that? Okay, if I divide it by 2, that's where we're going to start. Dividing by 2, we get 59.65. But does that really give us the piece we want? Not quite. It cuts us right here, doesn't it? We got this little rectangle here that's extra, but we know that rectangle is 12 feet this way. How about this way? It's, yeah, half of this side, half of 4.97. So I take that 59.65, I'm going to subtract 12 times 4.97 divided by 2. 29.83 is what this area is here. We add to that the 12 by 20, which is 240. So 269.83 square feet is that area. You tell me if it would be easier. You have this amount here. Do we have this amount? We could find it. It's just, no, this amount isn't s. That amount is cosine of 45 times s. Now you have s. Yeah, you can find it. It ends up being, this was 4.97. This ends up being 3.5 basically over here. These end up being 3.515, if I remember right. So yes, it would be 3.515 by 3.515, and then 3.515 by 4.97. It's not, it's, yeah, probably a little bit easier than that way, right? But then I don't get to use my fancy polynomial formula. Okay, I've got another worksheet for you guys to do, and I'll let you guys have some time to work.